Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ali Vezat bin Azlan, and for our project for the ESD is we are creating the flood monitoring system using the Zinc 7000 SoC FPGA. So now I will show the step for creating the new project. Firstly, we open the Vivado software. From there, we click File, a new project. Here, we name our project just flood monitoring system. Here we choose the RTL project. Here we just click next, and the boards we use are the Zinc 7 ZC702. So here, after we click finish, I already created the file, which is this one. After we created the file, it will display like this. Next, we will try to create the block diagram. I already created the block diagram, so by opening the block design, I'm gonna wait for a minute. So here the block design. We have already created the block design, but if we want to add any other block, just click the add IP and search for GPIO. This. Here we go. Since we already added our GPIO, which is the LED and the moisture sensor, to connect all the system, we just click the run connection automation, which will automatically connect the processing system with the GPIO and the X2 IC. So that's how you create the block design for the system. Next, after creating the design, we'll have to validate the design to see if there are any errors in the design. Okay, there are no errors in the design. After that, we go to the sources, IP sources, to create the HDL wrapper. I already created the HDL wrapper, so we'll output like this. After creating the HDL wrapper, we have to generate the bitstream, which can take a while to finish. Here, save. Now we'll just have to wait for the generate bitstream to finish. So here the bit generation is completed and there are no error. So you open the implemented design. So the implemented design will be displayed on the device section here. After that, we just export the file to the SDK, to the hardware. So that is the steps in the Vivado software to create our project. So next, I will pass to my friend Shahrul.
Hi, Assalamualaikum Doctor. My name is Shahrul Zain Muhammad. Okay, today I would like to present about my part, explanation on security, safety, reliability issues in this project, our project, the flood monitoring system. Okay, by using the Zen 7000 SoC FPGA to implementation and optimize, we get the good security and reliability for our project. So for explanations, for reliability issues in this project architecture is to improve compilation performance. This is because we use a Vivado to develop our design. This implementation involved the Zin 7000 SoC FPGA, so it can improve resource utilization and more consistent reliable time closes. FPGA were thought to be better compared to ASICs and ASSP. However, they use more power and had worse performance. This gives improved communication, extension, flexibility, and capability between processing and programmable logic. So our fraud monitoring system will become efficient. So next, for security, fraud monitoring system meets stringent requirement for security. It is because Zin platform has many features that aid design team's effort in designing safety features and secure operation. In addition, Zin device include unit anti-tamper AT technology. These features are critical not only for the defense program but also for commercial customer who are looking to protect their IP. So by using this Zin and FPGA, so I think our design will be more secure for security part. Okay, so that's all for me, Doctor. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hafiz Iskandar, and I want to talk about the sustainability aspect to consider when we using the Z-Link ZenQ7000 series SoC in the flood monitoring architecture. Okay, there are several sustainable aspects for this project. One of these is energy efficiency, which is using the ZenQ7000 series SoC. It will use low power consumption that can help minimize the energy usage of the flood monitoring system, which is a critical aspect of its sustainability. Next is the flexibility of the ZenQ 7000 series SoC, which is allowing it to be customized to to the specific needs of the flood monitoring application that can help to optimize the system for performance and efficiency. Next is we are using the ZenQ 7000 series SoC. FPGA is a reusable program that can use on a different application, which can help extend the life of the flood monitoring system that can reduce the need for replacement parts. Also, using ZenQ 7000 series, our project, which is flood monitoring system, can be remote monitoring, which can use the IoT device and wireless communication technology that can remotely monitor it, which reduce the need for the on-site maintenance and the human intervention. Also, Zingu 7000 series SoC allows to add more functionalities and sensors to the system to make it more capable and scalable. And lastly, it's about data management, which is uh, proper data management strategies like the data compression, data filtering, and data storage on the cloud server can help in reducing the energy consumption and prolong the life of the flood monitoring system. And that's all from me and my group. Thank you.